In the last video, we had a look at compound angles. So we've been journeying through trigonometry. We've got so much base knowledge to work from, and now we get to build on it with this matric work. So we learned that there are compound angle formulae, and these are given to us on a formula sheet. And what we're going to do now is we're going to build on our knowledge of compound angles. And we're going to say, what happens if the angle is the same? In other words, what happens if we have what is known as a double angle? So sine of 2a or cos of 2a or whatever the angle is. What happens then? And what you'll see is that we can expand this, and everywhere that we would normally have put an a and a b, we've now just got a's. And this can actually be summarized quite beautifully into what is known as the double angle formulae. And here they are. And you will be relieved to know these all get given to us on the formula sheet, but it is helpful to be very familiar with them so that you don't waste time paging around looking for different formulae. Okay, so if we took the sine and we made it a double angle, you'll see quite easily it becomes sine a cos a plus sine a cos a, and so there are two sine a cos a's. So that one is simple, and there's just one alternative for the sine double angle. Okay, and it has to be two identical angles in order to be considered a double angle. Cos, on the other hand, brings us a couple of options. So the first and most obvious one here is cos a times cos a is cos squared a, and sine a times sine a is sine squared a. But then, if you remember back to that fundamental identity that we learned in grade 10, we learned that sine squared plus cos squared is always equal to 1. And so what they've done is they've taken this fundamental identity and they have substituted it out. And that's why we've got so many options here to work with when it comes to the cos double angle. Is that it is cos squared a minus sine squared a, but it could also work as 1 minus 2 sine squared a. And you can go check that out. Go see how to sub that out. And similarly, it could also be substituted as 2 cos squared a minus 1. Okay, so as I said, these are also given to us on the formula sheet, and so we just need to know that if we're given an angle that can be broken up into two different things, that's when we make it a compound angle. But when we get given an angle that is two identical parts, that's when we're going to use these double angle formulae. Let's start by putting our knowledge to the test, and so we are just asked to expand the following. Okay, so cos 80, in the context, we wouldn't often just take cos 80 and make it a double angle. We'd look at what else we are working with, but because we are specifically learning about double angles, that's what we're going to do now. So here are all the double angle formulae, and you'll see we've got so many options, okay, because cos has got 3 different options. So let's dive in and see what's going to happen. The first thing we need to do, grade 12s, is we need to break this up into a double angle. So 2 times how much gives us 80. Okay, and because we're working with doubles, we want it to be 2 times 40. Okay, and now we've got options. We can do all of them, and I think we should do all of them just to practice. So the first option is to say, well, that is equal to cos squared 40 degrees minus sine squared 40 degrees. So that's the first option ticked off. Then we could also just go to the second option, okay, and you really need to look at these things in context to be able to decide which one to use. So don't worry too much now. It's better to have more options than to be left with no options at all. So don't panic. But in this case, we could also say this is equal to 1 minus 2 sine squared 40 degrees, and another option we could say here is 2 cos squared 40 degrees minus 1. So those are our 3 options there for the cos compound double angle. And they are all correct. Okay, sine, on the other hand, as I said earlier, just has the one option. So let's take a look at that. Let's make some space there. So what we need to do is we need to break it up. And we need to say, well, this sine 4x can be written as sine 2 times 2x. Remember, we want to make some form of double angle. Okay, and then that one we can expand there. The formula, it's the bottom one there. It says 2 sine 2x times cos 2x. And then what we could do, if we were feeling fancy, is we could say, well, there are some more double angles. So let's do it just because it's good practice. So we're going to take the 2 that was already there, and then we're going to re-expand the sign. So now instead of 2x, it's just going to be x, right? Because we're doing the double angle. So it's going to be sine x cos x. And then we have to do the next one, cos 2x. And let's take that and say that's going to be cos squared x minus sine squared x. Okay, now depending on what we're working with, often we get these in identities and then we see, we've got difference of squares here, and we can start to expand things and cancel. But in this instance, we are just focusing on applying the formulae. So I think we can leave it there for now. All right, let's see if we can do it back to front now. So we are given something that is expanded. Can we simplify it to a single term? Let's get those formulae in place so that we can refer to them. So we've got 2 sine 2 theta times cos 2 theta. So sine times cos, that looks like this double angle formula. So it's 2 sine something cos something. There we have it. And we can then compress that into a single term, sine 2 times that angle. Okay, so now don't get confused just because there are going to be a lot of 2's, but that's okay. So it's sine 2 times the angle there, which is in actual fact going to be sine 4 theta. Okay, so there we've taken something that looked very long and we have condensed it into something nice and short. Okay, and then the next one, 2 sine x over 2 times cos x over 2. So looking at it again, 2, that's cool, sine angle cos angle, sine angle cos angle. So that's again the sine double angle. Okay, so we're going to write that as sine 2 times the angle there is x over 2. Okay, and that's just 2 over 1. So we can then simplify it. 2 goes into 2 once and into 2 once. And so we're actually left with something very neat and tidy. Sine x. Okay, that looks like a nice answer. Let's try some more. So cos squared 5 alpha minus sine squared 5 alpha. So we should be so in tune to the sine squared plus cos squared equals 1. But now we need to shift and we need to say, oh, okay, if they're not adding, then perhaps we are talking about one of these double angles. Okay, so let's look specifically for cos squared minus sine squared. Okay, and that's the very first one here. So cos squared minus sine squared is equal to cos 2 times that angle there. So we can then rewrite this whole long thing and we can say it's cos of 2 times the angle there, 5 alpha. And so that's actually just cos of 10 alpha. All right, let's look at the next one. 1 minus 2 sine squared and then an angle there. Okay, so having a look again at our formula, 1 minus 2 sine squared of an angle. That's great. Okay, the angle is a over 2. The angle here in our formula is just a, but that's okay. We can adapt. Okay, and that can be condensed into a single term, cos 2 times the angle that we're working with. So let's do that. Cos 2 times that angle there, a over 2. And what happens when we times 2 by something that is being divided by 2? Well, those simply cancel, and so that becomes nice and neat, cos of a. Right, and then it was inevitable. Special angles are forever slipping in. And so if they ask us to determine something without using a calculator, then that needs to be in the back of our minds. How can I use special angles here? Okay, but 15 degrees is not a special angle. So now we're going to combine our knowledge of double angles with our knowledge of special angles. So let's get those double angles in place, and then we can see what exactly we are working with. Okay, 2 sine angle, cos angle. If we look at these formulae here, it's this one right at the bottom. 2 sine of an angle, cos of an angle. We can rewrite that as sine 2 times the angle. So that's going to be our first step. We're going to say sine 2 times the 15 degrees. Okay, and 2 times 15 is just 30 degrees. And we are very happy now because 30 degrees is a special angle. So here we have our special angle drawing. We look specifically at this 30 degree line and we say sine is y over r. So 1 over 2. That becomes such a nice answer from something that looked so very abstract. We then used our double angles and then our special angles. Okay, let's test our knowledge again here with this second example. So 1 minus 2 sine squared of an angle. Let's have a look. Here's one that starts with 1. 1 minus 2 sine squared of an angle. That can be condensed into cos 2 times the angle. So we can rewrite this then as cos 2 times 22,5 because that's the angle there. 22,5 times 2 is just 45 degrees. So cos of 45 degrees. Cos is x over r. So looking at the 45 degree line, the x value there is root 2 over the r value there is 2. So that can be written as the root of 2 over 2 there as our final answer. So once again, we identified it as a double angle. And we're lucky in this video because we know we're working with double angles, but it's very important to get good at recognizing them because once we put everything together, they're not necessarily going to guide us like that. We're going to need to know and recognize these very quickly. So that's a double angle, and then we could use our special angles. Well, let's see what happens then when we do start to combine some of these concepts. So here we are given sine of 36 multiplied by cos of 36, and then that's over tan 225 times cos 198. So before we can get to anything here to do with double angles, we're going to have to do some reductions here. So there's the class diagram, which is something that's not given to us. We need to know it. And that's going to be used here in the denominator. So we're going to take sine of 36, and that can stay, because at the moment that's an acute angle. Cos of 36, also an acute angle, so that's fine. Over tan 225, we're going to have to rewrite. So that's 180 degrees plus 45 degrees times by cos. That's also going to the 180 quadrant, 180 plus 18 degrees. Okay, now we use the cast rule to reduce. So sine 36, we're not ready to do anything with it yet. Cos 36, not ready to do anything with it yet. Over tan in quadrant 3, the 180 plus. Tan is positive there. So that becomes tan of 45 multiplied by cos in the 180 plus quadrant. Cos is negative there. So that's going to multiply by a minus cos of 18 degrees. Okay, now what we want to do is we want to have a look. Tan of 45, that's a special angle. And at matric level, we actually know straight away, we know our trig graphs, tan of 45 is equal to 1. So that part is technically going away because dividing by 1 is not going to change anything. Okay, so let's take our sine of 36, cos of 36, and then here in the denominator we've got cos of 18, which is not super helpful because what I'm noticing here is sine cos, which looks a bit like this sine double angle here. Okay, it's missing the 2, but it looks a little bit like it. So that's what's guiding me here. And so what I want to try and do is see if I can change this cos to become a sine. And remember, that's a little process called cofunctions. So we ask ourselves, 18 plus how much would give us 90 degrees? Because that's how cofunctions work. So 18 plus 72 degrees would give us the 90 degrees there to make it a cofunction. And so then we can rewrite that as minus cos of 90 minus 72 degrees. And that will allow us make a cofunction in our next step. Okay, so this is then sine 36 cos 36 over minus sine 72. Okay, and have a look there. Do you notice that 72 is actually the same as 2 times 36? Okay, that was our goal, is we were learning about these double angles. So now we want to see how we can use them. So then we can rewrite this as minus sine of 2 times 36 degrees, because that's going to help us to expand. Okay, so let's carry on with this question up here. And so what we're going to do now is we're going to say, well, sine 36, haven't done anything with it yet, times cos 36 over minus, and then we're going to expand this now, 2 sine 36 cos 36. Okay, that's fantastic news. So if you look at it, there are no pluses or minuses in my numerator or denominator, or not separating terms. It is an overall negative, but that's okay. I am allowed to cancel. So sine 36 may cancel with sine 36. Cos 36 may cancel with cos 36, which leaves us with just 1 on top. And so the final answer here is minus a half. So there we've taken our knowledge of reductions and the cast rule. We've combined some special angle knowledge there. And then we saw how we can use these double angles to simplify.